See the sixth one. Find the intervals in which the following functions are strictly increasing or decreasing, correct? So we are trying to figure out what is the interval. So we have already done one sort of like an interval type of question, very similar to that. So the first one, minus 2x cube minus 9x square minus 12x plus 1, right? Differentiate. When you differentiate f dash of x, this is going to become minus 6x square minus 18x minus 12. Equate this to 0. You can divide by minus 6, right? You'll get x square plus 3x plus 2 is 0. Or you can write this as x plus 2 into x plus 1 is 0. Remember splitting the middle term type of questions. So what are the values of x now? So x is either minus 1 or minus 2, right? So what do we have? We are going to have 2 points here. Very important, 2 parts we are going to take. So imagine this is your number line. Okay, this is 0, or maybe I'll take the 0 value a little bit here because we have minus 1, minus 2, right? So maybe this is 0, minus 1, minus 2, minus 3, so on and so forth. First, we'll do from minus 1 and greater than minus 1. Any value greater than minus 1, if you are going to substitute, see what you have x square plus 3x plus 2, right? So this is your f dash of x. Remember, this is your f dash of x. See, since you have f dash of x here, substitute 0. If you substitute 0 or any value which is greater than minus 1, you are going to have a positive value. That means this part it is increasing. Correct? So this is increasing. Now any value less than minus 2, any value. Like say you take minus 3, minus 4, anything. Let's take x as minus 4 and check. Suppose if x is minus 4, this value is going to give me minus 16. Sorry, 16 minus 4 square is 16. Then minus 12 plus 2, which is still positive. That means this is also going to be increasing function. Right? Now, in between, when you do it, in between, that is from minus 1 to minus 2. Say you take minus 1.5, something like this. So if you take minus 1.5, so you will have, that's minus 3 by 2. Minus 3 by 2 whole square is 9 by 4. Then plus 3 into minus 3 by 2. Correct? So minus 9 by 2 plus 2. Right? So 9 by 4 minus 9 by 2. 9 by 4 minus 9 by 2 is minus 9 by 4. So you have minus 9 by 4 plus 2, which is going to give us minus 1 by 4, which is negative. That means in between we have a decreasing value. So what do we get? Anything more than minus 1 is positive. Anything less than minus 2 is positive. In between we have negative. Isn't it? This is what we have. So we have increasing function, we have a set of interval. Decreasing function, we have an interval. So let's write down the interval for which it's increasing and decreasing. All right. For the increasing part, we have from minus infinity to minus 2 union minus 1 to infinity. This is for increasing. Correct. Now for decreasing, it is from minus 1 to minus 2. This is for decreasing. Okay. So this is the answer for the first one. Fine. Let's do the second one now. Very similar to this one. All right. Second one. 6 minus 9x minus x square. Differentiate. When you differentiate, f dash of x becomes minus 9 minus 2x, right? Or equate this to 0. So when you equate it to 0, you'll get 2x plus 9 is equal to 0. X is equal to minus 9 by 2, right? So now again, so you're going to take the number line. This is 0, 1, 2, 3, minus 1, minus 2, minus 3. Okay, so minus 9 by 2 is minus 4.5, isn't it? So I think it's better if you take the numbers a little bit this side. All right. Say this value, we'll call it as 0. 1, 2, minus 3, minus 4, minus 5. Say this is 1. Now minus 4.5 is somewhere here, correct? Minus 9 by 2. Now we'll take any value greater than this, maybe like 0, minus 1, 1, whatever you can take. Okay. Say we'll take a value of x as 0. All right. If x is 0, then f dash of x. Suppose x is 0, then f dash of x, or you can say f dash of 0. This is going to become minus 9. Right? This is going to become minus 9. So when f dash of 0 is minus 9, is it negative or positive? It is going to become negative. So this part is going to be decreasing. All right. Then anything less than minus 9, say you have minus 5 or minus 6 or something like this. Say minus 5 you have. Simple number, say minus 5. When you have minus 5 here, f dash of minus 5 becomes minus 9 plus 10, which is 1, which is going to be increasing. Right? So for the second part, the increasing part is going to be minus infinity to minus 9 by 2. This is increasing, correct? And for the decreasing, it's minus 9 by 2 to plus infinity. This is for decreasing. So we got the answer for second one. Let's do the third one, that is 6C now. Now you have x plus 1 whole cube into x minus 3 whole cube, right? Differentiate. F dash of x is equal to 3 into x plus 1 whole square into x minus 3 whole cube plus 3 into x plus 1 whole cube into x minus 3 whole square. So this is the value. Now we'll equate it to 0 and get the points. All right. When you equate this to 0, all right, you take common. See, you have 3 into x plus 1 whole square into x minus 3 whole square. This is common into x minus 3 plus x plus 1 is equal to 0. Right? So when you have x minus 3 into x plus 1 is 0, what you can do, you can divide this. That means either this 3 anyway you can take it off. 3 is not going to matter. Either x plus 1 into x minus 3 whole square, this is 0, or see x minus 3, this part, x minus 3 into x plus 1, when you take it, you'll get 2x minus 2 is 0, or x is equal to 1, right? Either x is 1 or this value is 0. That means in this first part, when you take it, you can take x is minus 1 or x is 3. X is minus 1 or x is 3. So now we have 3 points. We need to look at these 3 points and then we need to go about it. Understood? So let's draw the number line and do it. 0, 1, 2, 3, 4, minus 1, minus 2, minus 3. Okay, now the first point what we'll take x as 1. Okay, so this is 1 point. Another one is minus 1 correct? And another one is 3. So we need to take 3 intervals. So first we'll do from -1 to infinity, -1 to 1, 1 to 3, 3 to infinity, correct? Now when you're doing this, see what you're going to get. The first part, when you apply the value, so when you apply the value, you have x plus 1 into x minus 3 whole square into, you can write 2x minus 2, right? Apply value of say x is equal to -2. This value is always positive, don't have to worry. When you take x as -2, -2 into 2 is -4 into minus. So this is always negative. So this is going to give us decreasing, no matter what you take. Okay. So -1 to 1, say you take a value of 0. If it is 0, this is positive, this is negative. This is also decreasing. Okay. Now the next one, 1 to 3. 1 to 3, take any value. This is positive. Say you take a value of 2. This is positive. So it's increasing. This is also increasing. So these are the intervals. All right. So let's do the next one. See the 7th one. See, you have prove that this value or this function is increasing from 0 to pi by 2, where 0 and pi by 2 are included, right? So we do dy by d theta. So when you do this, guys, you have to apply this one. What is it? The quotient rule. So when you apply the quotient rule, 2 plus cos theta whole square, numerator 4 cos theta into 2 plus cos theta first, minus 4 sin theta into minus sin theta minus 1, correct? So this is what you have as the dy by d theta. Now to show that it is an increasing function from 0 to pi by 2, now you have differentiated. Now we need to apply values in 0 to pi by 2, including 0 and pi by 2. All right. Suppose if you take a value of 0, we'll start with 0. All right. So what if theta becomes 0? Now if theta is 0, then the first part, that is the cos theta part, see, this is going to become 0, this is going to become 0, correct? Now cos value will have to substitute. 4 into cos 0 is 4 into 2 plus 1 is 3 divided by 2 plus 1, 3 square, which is 9, right? Minus 1. So 12 by 9 minus 1, or you can say this is 4 by 3. 4 by 3 minus 1 is greater than 0. So dy by d theta is greater than 0. The first part is done, so you proved it is positive. Now, what if you are taking another extreme value, which is pi by 2? So theta, let's take pi by 2. So when you're taking pi by 2, cos pi by 2 would be 0, correct? And sin pi by 2 would be 1. Now comes the very important part. So here when you take pi by 2, the cos part is going to get cancelled, isn't it? So that means this will be 0, this will be 0, this will be 0. So what do you have then? You are going to have minus 4 into minus 1 divided by 2 square, which is 4, minus 1, right? So 4 and 4 cancels. So what do you have? 1 minus 1, which is a 0, isn't it? So what we are going to have now, when you take theta as pi by 2, you are going to get it as 0. Sorry, yeah, you are going to get it as 0. Now, how are we going to prove that it's an increasing function? Because at pi by 2, we are getting it to be 0. Because remember, whenever we have f dash of x to be 0, it's neither increasing nor decreasing, correct? But the trick here is they're asking you in that interval that is from 0 to pi by 2, isn't it? So we need to look at that particular interval. So we'll take a value between 0 to pi by 2 now. Okay, and we'll check whether it's going to be positive, 0 or negative. Fine. So let's take a value. Maybe we can take pi by 4 or you can take pi by 3, something like this. Okay, we'll take a value in between the range of numbers now. Fine. Now we'll take theta to be pi by 6. Fine. See, when theta is pi by 6, what do we have? 4 cos pi by 6. Cos pi by 6 is root 3 by 2 into 2 plus root 3 by 2 minus 4 into half into minus half by 2 plus root 3 by 2 whole square minus 1. Quite big numbers we have. But we are not going to look into everything. The reason is minus into minus. Here we'll get plus. Correct? Minus times minus is plus. Now, is this value more than 1 or less than 1? That is my only concern. And that should be the only concern for you guys also. Because if the left side part, that means if this entire value is greater than 1, then you know it is going to be a positive number. Correct? That's all you need to do. You don't have to do anything else. So 4 into root 3 by 2. So you can cancel the 2 here. Correct? And then here also you can cancel the 2. You'll get it as 1. Isn't it? So we have 2 root 3 to 2 plus root 3 by 2 plus 1 by 2 plus root 3 by 2 whole square. Now 2 plus root 3 divided by 2 is going to be 4 plus root 3 by 2. So the overall value of the left side is going to be greater than 1. Alright, overall value. The reason why I'm telling this is we can take the 2 plus root 3 by 2 as common and we can cancel. Fine. If you cancel and if you simplify, the left side part is going to be greater than 1. So since you have that to be greater than 1, what we can tell is in this part, for theta is pi by 6, f dash of pi by 6, I think not x I would say here, f dash of pi by 6 is greater than 0. Since this is greater than 0, we have an increasing function. So the function y is an increasing function in 0 to pi by 2. In that interval, it is an increasing function. Fine. So this is how you need to solve the 7th one. And this is the answer what you're going to get. Let's do the next one. See the 8th one. So the function f of x is equal to log of sin x. Strictly increasing in 0 to pi by 2 and pi by 2 to pi is decreasing, right? Differentiate. F dash of x is 1 by sin x into cos x, which basically becomes cot of x, right? Since this is cot x, now 0 to pi by 2. Now we all know that cot x is positive in the first quadrant, right? So what do we have? F dash of x is greater than 0 for all x belonging to 0 to pi by 2. Because cot x is positive in the first quadrant. Since cot x is positive in the first quadrant, directly we can say that f dash is positive. So since f dash of x is greater than 0, we can say that this is an increasing part, which we were supposed to prove and we just proved it. So it is strictly increasing. And in the second quadrant, that is from pi by 2 to pi. Now in the second quadrant, which is positive, sine and cosecant, not cot, right? So here f dash of x is less than 0 for all x belonging to pi by 2 to pi, because it is in the second quadrant. So this is going to be a decreasing function. So we proved that it is strictly decreasing. Fine. So we just proved that from 0 to pi by 2 it's increasing, pi by 2 to pi it is decreasing. Correct? Now let's do the ninth problem. See the ninth one? Prove that the function is increasing in R, right? R is what? Set of real numbers. So here f of x is x cube minus 3x square plus 3x minus 100. Differentiate f dash of x 3x square minus 6x plus 3. Now we need to show that this value is always greater than 0. For that, maybe you can take 3 as common. 3 into x square minus 2x plus 1. Right? And what is this value? 3 into x minus 1 whole square. X minus 1 whole square can never be negative. That means, what do we have? This particular term is always positive. 3, obviously it's a positive number. So no matter what the value of x we are going to take, any real number, x minus 1 whole square is always positive. And you're multiplying that with 3. That means what we are going to get? F dash of x is always greater than 0, irrespective of what the value of x is, right? So f dash of x is greater than 0 for all x belonging to R. Correct? So since it is always positive, the value f of x is always increasing in the set of real numbers. Alright. Now these are certain problems what we have discussed based on increasing and decreasing functions. Now in the next video, we are going to discuss about the next application of derivative, that is tangent and normal.